In this episode, I have a Sony EVS3000. This is a Hi8 deck with a built-in time-based corrector, and it also will process PCM sound. So it was one of their high-end decks. Actually, it was their high-end deck. Was replaced with the EVS3000, which basically added just a time code generator and time code reader. So this is like an EVS3000 without the time code, and it's got some serious problems. This time I've got an EVS3000. This was a Hi8 player that recorder that Sony had a few years back, and this one also has the time-based corrector. I think it's got time-based corrector. Yeah, time-based corrector, digital noise reduction, digital comp filter, and of course PCM stereo sound. This was the first of the home decks that Sony offered. Does not have time code on it. I had one of these decks for a while. Got rid of it years ago when I moved up to the EVS3000 and the EVS5000 because I needed the time code. This unit featured removable wood side panel so that would match their ES or expensive shit home products. Here's the deck on this one. One thing you'll notice on this one is it uses a different tape transport. This tape transport is more like the camcorders of the day, and you'll recognize them being completely different than other ones that we had. When I load a tape onto this one, tape loads just like that. So let's just see what happens when I press play. Sound problem. I don't even have a picture. Rewind the tape a bit here. I might be beyond where there's a recording on the tape. I don't think this tape's full. Okay, I got no picture. This is gonna, I'll show you the picture on this thing. This is going to be probably capacitors on this unit. You see. This one here is probably going to be capacitors in the video circuit. And the power supply. Looking pretty sad. And the time-based corrector. Looking real sad. It's not good news. How about if I pause it? No, that's not going to do anything. This unit is what we call... Even when I pause it, there's nothing. Foobar. That's what this one is. This one is Foobar. Search. When you buy one of these things used, 9 times out of 10, this is what you're going to get. And it's going to cost a lot of money to fix it. Okay, we can even see the signal coming through the tuner is in pretty bad shape. It does not look right. Look at all the wiggle in there. Go into my security cameras. Look at how bad they look. So this one, I'm not so sure where the fault is at this point. It could be a power supply problem because we're not only having a playback video problem, but we're having a problem just even getting a signal fed through from the tuner. I'll plug it in. Right now it's going into the line out. Let's just see whether, okay, there's the other output. There's 2 sets of outputs on here. As you can see, the 2 sets of outputs actually have a different picture. Well, different quality. That's the monitor out, I believe, that I'm plugged into. Yeah, that's monitor out. So that would have the on-screen graphics. The other output is the line output, and as you can see, the line output is even worse because the picture is halfway between frames. You're seeing the sync pulse from. Well, we're seeing it on this one too. So we have a big problem on this unit. And the fact that it doesn't play as well. But it's got a timing problem.
Asked Jason McQuiggan for the 17th. He learned for the first time that Jason never.
On a unit like this, the first place I can think to start is in the power supply. I don't know that that's going to be all of the problem with it. I think there's probably more problems than the power supply on this unit. We'll pull the bottom off of it as well, just to take a look into the bottom of this unit. This one was at Sony, it looks like, at some point. These units were not trouble-free units. I got rid of mine when I bought my EVS3000, but I was having capacitor problems with mine when I got rid of it. And that was years ago, because I got my EVS3000 when they first hit the store. These were not a good deck. I would say don't buy one. They do come up on eBay, and I would say stay away. Run as far as you can, because these ones here are very notorious for problems. That is, unless you don't mind spending a lot of money to get them working, because there's a lot of work to be done on these units, as you'll see. Now, I know you're going to say, well, I don't see any surface-mounted electrolytics in this thing, so how much problems can this one have? It's just got some regular through-hole caps, right? Yeah, right. This is a time-based corrector, and they fail. The caps in here leak onto the board and cause damage. And this, of course, is part of the main video processing. Here's a look in the top. Audio FM is down here. This was the PCM, so digital audio is in here. PCM board, or PCM section of the board. AFM is here. I think this one's the video board. Wide gain and chroma gain. Yeah, this is the video board here. This other one here that I showed you about down below with all those surface mounted caps in it, that's the time-based corrector board. And that gives trouble. It failed on mine before I sold it. It's one of the reasons I sold mine, was because the time-based corrector board went bad on it. I put a new TBC board in it when the boards were available. Was able to swindle one out of Sony for a warranty. How we used to do that, I can talk about this now because the business is gone, but how we used to do that is when we had one that was bad. Oh, our display model that we have in the showroom that we've had for sitting here for 2 years, it's gone bad. And we got to fix it, because of course the warranty starts when the unit gets sold, not when it's put on display. So we used to put warranties through long past the warranty was up, because we would just put through the warranty and claim it as the store demo. So I put a new TBC in mine, and then found some sucker to buy it from me, working. But because mine had died within a couple of years, I figured it was time to unload it, and I wanted to move up to the EVS3000, which was a better deck, with the exception of that bloody of the gear that goes bad. I just want to take a look in the power supply on this thing, and power supply should just unplug and lift out of this one. The fact that I've got problems on both the E2E video and playback indicates it could be a common problem in the power supply. We could have ripple or something getting on one of the rails. So first things first, let's get into this power supply and see if there's any bad capacitors in it. Oh, and we know that there is, because you can see it here. You can see where they have been leaking. So perhaps I'm going to get lucky, and I'm going to be able to just change out some caps in the power supply and get this one working. Unfortunately, this is not an easy one to work on because of the way that this thing's constructed. I got to remove the board. First things first, though, I'm going to make sure that the high voltage capacitor here is discharged, because I unplugged it and I don't know whether it's drained or not. So we'll just measure across the main filter and see that there's only 0.8 volts remaining, so it is dead. So I don't have to worry about getting bit by anything in here. So I'm going to remove the screws, and that should be able to lift the board out to work on it. And fingers crossed, the video symptom I'm getting is caused by power supply. But likely it's not. Likely there's faults in that time-based corrector as well. Unfortunately, with the design of this is how I've got to work on it. It doesn't come out of the power, or it doesn't come out of the cabinet anymore now. So it's got to be worked on like this. And yeah, before you guys even ask, they're shitty Elna caps. See, I can say it that way. Elna shit. So there's a bunch of them that are leaking here. C11, C14, C42, C19, C20, C12. These are all going to be bad. Every last one of these. We'll pull C11 first just because it's the easiest one to get to right now. Probably only one lead's going to come out of the board. Maybe both of them will, but guaranteed this is leaking. Guaranteed. Oh yeah. It's leaking right now, actually. You see, when I powered this thing up, it started spewing on the board. Elna, 1000 microfarad, 16 volts. Bad. Take out the next one, C14. It'll be bad as well. Yummy. Another 1000 microfarad, 16 volt. And we'll go to the next one, which will also be 1000 at 16 volts. Ooh, snapping and crackling and popping. It's toasty. Another one, 1000, 16, just as bad. And the other ones that are going to be bad are these other ones over here. All these brown ones I think are probably shot on this unit. C19 and C18 for sure, which are down here. They're smaller ones. C20, C16. Let's take them all out. I don't know that I've got enough. I may have to make a trip in to the parts store to get some new parts, because I don't know that I've got enough to do this one. That's C18. .330 at 16. And this other one here, C12, I think 19 and 20 are also bad. Although they're not the same caps. These ones actually might be okay because they're not Elna. They're a different brand. I think these ones are probably okay. It's just these brown ones. These 1000 and these 330s. C12. If it hasn't failed yet, it will. Yeah, it's bad. Another 330. 330 at 16. Are we seeing a common multiplier here? Common denominator? All these 330s and 1000 microfarad caps. And another one bites the dust. This one's also a, oh, this is a 470. A 470 at 10. This is probably a 330 here. This one here, I'm sure this one's also bad. This might be all the ones in here that are really, really bad. This one actually hasn't blown, but it's a bigger one too. This is not an Elna. This is a Nikon. So this one's probably okay. Let's measure it with the ESR meter. I bet you this one's okay. I can put this one back because it's not leaking. And Nikons typically didn't have the problems that the Elnas did. The Elnas were just awful. Okay, let's just measure this one. I'll bring the ESR meter in, zero it out. Let's see how this one scores. 0.05 for 470 at 25 volts. 0.12 is considered to be what a new one would be like, and this one's 0.05. So this one is fine. This one can go back into the set because it's bad. It's fine. It's just those other ones that are all spewing their guts. So this was C15. I'll put that one back in. We'll clean up the board. Okay, I found 3,000 microfarad 25 volt caps to go in here. So we get these ones soldered in, and then I'll replace the other ones, and we'll check the board for any traces that are open, and put the power supply back in and give it a try and see whether I've made any changes to the way that it operates. I can say for sure that something's going to change, that's for sure. It's going to be an improvement. Whether it's going to fix it totally or not, I don't know. I'm hoping that it will. I'm hoping that the fault with this was just there was so much ripple coming down from the power supply that it was just causing all interference. That's what I'm hoping is the fault. Replace the other three. C16 was a 470, and the other two were 330s. I'm just tacking these in right now, and I'll do them properly once I get the board over on the back so that I can properly solder them down. Foil might be damaged here. I just want to kind of scratch away some of this solder mask, just so I can see that if there's any shorts, any bridges or anything here, because this is in pretty rough shape. Also, the way that this gets eaten through like this, the electrolytic is corrosive, so it can actually corrode and open the trace. So that's one of the other reasons I'm taking off the solder mask, is just so that I can inspect the copper. I may have to go over the copper here. I probably will have to go over the copper just to provide a little bit better continuity. Now, people ask me why these caps fail. What's the cause of it? Now, I'm not a chemist, so I really can't comment on why they go bad other than what I have read. And what I read about this many years ago in some technical journals that we used to get, we used to subscribe to these journals at the shop that I worked at. It was a group that I was involved with, an internet group of technicians. But what was discovered was that older capacitors made in the 60s and 70s and to the late 70s, they were all based on oil. They're all oil-based capacitors, and they all contained a type of oil called PCBs, or abbreviated PCBs, which stands for polychlorinated biphenyl. They had PCBs in them, and they were also in a lot of the fluorescent ballasts of the day. And PCBs are really bad chemicals because they are carcinogen, and you know, they never break down. They never break down. They're a man-made chemical, and it's a synthetic oil. That's what it was, and they never break down. You know, 1,000 years from now, PCBs are still PCBs, and they're a real environmental problem. You know, they weren't a problem when they were in the capacitors, because as long as the device wasn't disposed of. But the problem that happened was once the device was disposed of, and these capacitors could get crushed and leak, and then the stuff would leach into the groundwater, and the groundwater will eventually at some point make its way into the drinking water, for people that are on wells, for example. It's bad. It's bad for the environment. It would make its way into the food chain. It would leach up from underground if it was buried, and animals would drink the water, and then it would get into the other animals would eat those animals, and it would be washed out to sea in rainwater, and fish would eat the plankton that ate that were in the water, and they'd get contaminated with PCBs, and eventually we would eat the fish, and we would get contaminated with PCBs. So they're really nasty stuff. So they banned PCBs, and the manufacturers had to come up with an alternative. And the first alternative they came up with was an oil based on fish oil. That's why these things, a lot of times when they fail, they smell like the back end of a tuna schooner. They just reek of dead fish. And the fish oil caps, the biggest problem that I understand that they had was, first of all, the fact that they didn't last. But the reason they didn't last was because fish oil is not very stable. Being an organic compound, like most organic compounds, they were subject to environmental change. And what happened on these capacitors that were based on fish oil was the pH was not very stable. So you want the pH to be neutral. You don't want it to be low or it's acidic. You don't want it to be high or it's caustic. And the problem, from what I understand, happened was that the electrolytic inside these old crappy caps, well, it wasn't very stable. The pH varied a fair bit, depending on whether the capacitor was charged or discharged. And a lot of times what happened, especially with units that were sitting around for a long time, is that the electrolytic went to the base side. It went high and became caustic. And when it became caustic, it started to eat away at the rubber, make the rubber turn real soft around where the leads are, and also eat away at the copper leads that are going through the part. And eventually the seal would fail. And then when the unit got powered up again, of course there's always a bit of pressure that builds up inside when they warm up. The now free to leak electrolytic was just basically sprayed out of the capacitor itself and onto the circuit board, where it would now, of course, not be charged because it's no longer in a capacitor, and it would turn to like a slightly base or alkaline solution that would eat away at the board. And because it wasn't water-based, it wouldn't evaporate. If it was water-based, it would just evaporate. But these weren't water-based, they were oil-based. They were fish oil-based. That's what I read on it way back. And that companies would put additives in to keep the electrolytic solution stable. But sometimes they didn't get it right, and they did not stay stable, and then you ended up with failure. Now the next phase of capacitors that came out after these failed initial high temperature crappy fish oil based capacitors were the newer water-based capacitors. The problem is water boils at 100 degrees Celsius, and these things operate a lot of times at over 100 degrees Celsius. So they have to put a stabilizer in them to keep the water from boiling. And the initial ones that were produced, they may have been rated at 105 degrees, but the water was still boiling. And what happened on those, and you'll see those ones, the classic blown top, where they have vented due to internal pressure. They will pop that little vent on the top, which is an intentional weak spot. That's designed so that if the pressure goes too high, it will split there and the capacitor will vent and it won't explode, as used to happen with capacitors that did not have a vent. And if the pressure got too high, they were like a little bomb going off inside. Capacitor would literally explode, and you'd end up with pieces of foil and pieces of paper and the can blown all to pieces somewhere inside the unit. Those were the fun days when we used to find a blown cap inside wherever, I'll tell you. And it was even more fun when they blew up when you were working on it. Like, you put one in backwards and it didn't just go up in smoke. It actually exploded. Like the one I staged, and I know I think I've talked about this, the opening that you saw on this, the capacitors that blew up, they were staged. I actually put one in intentionally backwards just to film it blowing up on a machine that I was repairing. I put a cap in backwards to demo what would happen if it blew up, or if it was installed backwards. But that never made it to the video. So it was cut from the video, and the part was put in. A new part was put in, and the unit was sent on its way. And it was one that I worked on a long time ago. And the reason you guys didn't see it before is because I didn't want to show it too soon from when I fixed it, because the guy that brought that serviced the unit, the guy that owned the unit, who I serviced it for, may have seen the video. So I didn't want to draw any attention to the fact that I was using a customer's machine as a prop, basically. But it was a cap that I put in backwards, and I put in one that was really low. Like it was the power supply, I think, was a 20. The original one was a 25 volt cap, and I put in like a 6 volt, and I put it in backwards just to get that shot, and plugged it in, and it went boom, and spewed. But that was intentional. But anyway, that's what would happen on a modern cap. If that was an old one that did not have the vent, it would have exploded, and there would have been bits and pieces of capacitor everywhere. And they were kind of cool when they went off. Of course, you didn't want to be in the vicinity when one went off, because you'd probably get hit with the pieces flying out if the back was off. But anyway, that's a little spiel on crappy caps. Just looking at the board here to see whether that. I guess this one is connected. It looks like this one's connected to here and over to here. And this one runs this way back. I'm just going to get my meter out and just measure continuity, make sure that I've got continuity all the way through, and then we'll put this one back together and see what it does. Okay, I'll power it up and see whether it tunes any better than it did. Oh, okay. That's looking better. It's looking more promising. Check the picture out now off my TV. It's no longer all wiggly. It's actually looking pretty good. Well, that one's not looking good. Okay, now it's looking better. It's looking better. It's not looking perfect, that's for sure. How's the picture on playback? Probably no better. Yeah, no better. So capacitors were bad in the power supply, but this has got a lot more wrong with it than that, that's for sure. Let's throw some heat onto this time-based corrector board and just heat the capacitors up a bit, see whether the picture starts to come back. Chances are it will. Okay, now the feed through video is almost perfect now. See if I cool them down, whether the feed through video won't go bad. Got some circuit cooler here. There, you see? I've lost my sound. That's just from hitting the caps with some good old cold spray when I heat them up again. So the time-based corrector board, watch it snap in. I warm this board up a bit more, and I'm not putting the heat gun close to it. I'm holding it about 2 feet away, just so warm air is going onto the board. You see now, that time-based corrector board is bad. That's for starters. That's not the only thing that's bad on here though. But it's bad. I'm going to change a couple of them. I'll start out with these ones. These ones look like there's been some leakage around here, and this is the area where, when I was applying the warm air, this is where I got the results, was in this area here. So I'm going to just try getting those ones out of there. We'll swap it out and change it to a conventional cap. I'll try these two, the 47 here first, and the other one's a 100. We'll try that and just put a regular cap. There's room in here to do this. So You can smell it too. Yeah, stinks. Smells like so to try and narrow down which one of these, or which of the surface mount caps are the worst of them all. They're all bad, but which ones are the worst? I'm going to use my ESR meter, and we'll just go through and we'll just measure them in circuit and see which ones look bad, look really bad. Like that one there, 12 ohms, that's probably bad. It is bad. How about this one here? This one here is 7.1. That one's also not good. That one's completely open. So that one for sure that one's completely open. 0.2, that one's okay. That one there is completely open. Yeah, that one's completely open. That one's completely open. Every one of these is going to be bad. Open. 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 $12 ohms, that's going to be bad. 15 ohms, that one's bad. 3.2, that one's not as bad. Open. The ones I changed already were already open. 7.1. Open. Open. Every one of these bloody caps is going to be bad. Every single one. Yeah. Every one of these capacitors is bad. They all have to be changed if this unit is ever going to work again. So that's what we're going to have to do. I'm going to have to get a bunch of caps, and we'll start recapping this board once I get them. That's all I can do on this one. Otherwise, this unit's never going to work. Even at that, we still have other problems. We may still have some servo problems or any other number of problems with this unit. It's a problem when you're rebuilding these units that are old like this, is that you run into these problems. We'll catch you in part 2. Stay tuned.